Okay, here we are. I really don't want to do this, but I want to try. I'm wearing a mic, which might improve sound quality, and I'm at Schofield Park. I can't switch my cameras, so I'm going to have to turn my device around. And I'll show you. Here we are, parking lot. Those are the mountains. There's a few houses. This is Schofield Park. Santa Barbara's that way. And I'm your stupid teacher, and I'm going to try to walk down to the creek and show you around there. I'm going to turn off the camera for a minute. Okay, I walked down to the creek. So we were up there a little bit earlier. Now we are, I'll turn around the camera. We are here. You can see some steep rocky stuff, some rocks, a couple of pools. There was a pool over there. There's another pool over here. Maybe you can hear the water. I'm actually wearing headphones, so it's tough for me to hear it. You can see that we're mostly shaded by a canopy of trees. I hope I'm not moving the device too quickly. Probably not relevant, but these are these are all native trees. And here where we are, we get water from the Rattlesnake Fork Watershed. So from a ridge line all the way back there, up to East Camino Cielo, back behind those, all the way to this ridge line right over here, all of that land drains to this point. This is called Rattlesnake Fork. If you go that way, you get to Rattlesnake Trail. And if you go down the Rattlesnake Fork, you'll eventually meet the Tunnel Fork that comes out of like Inspiration Point, Seven Falls Trail. And then from there together, you've now made the main fork of Mission Creek. Concept that I want you to know there is that forks of a watershed come together. So that amount of land area plus this amount of land area makes a bigger total area that goes into a bigger main watershed or drain. I usually do this field trip in February. So normally it's green. But we're here now in November. It hasn't rained very much, so things are still pretty brown and dry. You can imagine we've accumulated a lot of organic material. See, all these dead leaves. There's more dead stuff. So this would be the natural organic material that would flood out periodically whenever we get a big storm. You can see there's a lot of brown stuff, but our biome is adapted to breaks in the rain. So there's also a whole bunch of living stuff. These trees are still alive. A lot of these bushes are still alive. This fern is alive. So is that fern. Right over here, there's some grasses and other shrubbery, whatnot, I don't know. And I'd like you to imagine what will happen here when it rains. Imagine if somebody were to dump a bucket of water right up there. That bucket of water would surely soak into the dirt, and you might get a little surface movement, but as that water moves, it'll continually soak in. If you dumped a bucket of dirt over there, I don't think it would reach my feet over here. If you dump a bucket of water over there, it would soak into the ground. All along this entire watershed, if it rains one bucket every square foot, this entire watershed, that water will soak into the ground and very little will come across the surface and carry debris down into the creek. Almost all of rainfall in this part of our watershed will absorb into the ground, recharge groundwater. And by the way, on the way there, some of that water will be removed by vegetation. That's how vegetation works, because roots and stuff. Now I'd like you to imagine, what if somebody were to take a poop right over there? Well, it would probably be acted upon by decomposers that are present here. This is a pretty happening ecological community. So there's going to be some crickets and some other bugs and some, I don't know what the heck, that would break down that poop a little bit. There's going to be some decomposers that are going to break down the organic molecules into basic nutrients. And I'll bet you a lot of those nutrients would be delivered by water to this plant, or maybe to that plant, maybe to this plant. So most of the time, if something poops over there, it'll be incorporated into this landscape. The nutrients will mostly stay, the material will mostly stay. It's not likely that that poop would make it all the way down to the stream. Even if it did, there's probably some stuff in the stream that will continue to decompose and absorb that material. What we have here is a diversity of habitats supporting a complex ecosystem that absorbs rainfall, decomposes waste, and generally traps nutrients, incorporates them into biomass. This has high habitat value. Wildlife likes this place. This has a bioremediation value. It helps solve water pollution problems, or things that would otherwise become water pollution. And let me see what else. Yeah, that might be it. Oh yeah. Sorry, I'm telling you, this is clumsy for me. Forgive me. One other thing. Imagine that this entire landscape above us is almost entirely wilderness. There's like a few houses, and there's a trail, and there's a roadway up there, and there's a couple more houses. But I'm going to say maybe from here all the way out to maybe here, we've probably got, I don't know, 30, 40, 50, 60 square miles with maybe a couple dozen homes, a few humans on foot, maybe a couple spots where a car could drive. But if you imagine, the runoff that comes off this would be almost all organic, biologically appropriate. The runoff that we would see coming down would be, bird poop, feathers, leaves, whatever's on the ground here, some dirt. There might be a couple cigarette butts from jackasses up on the trail. There might be some like dog poop or something, but humans aren't really adding a lot uphill over that many square miles. It's pretty pristine. Not a lot in the runoff that's been added by humans. I can't explain how awkward this is. I also can't use my notes while I'm doing this, so I'm just kind of winging it. But I think that's everything I wanted to say. We're going to leave Rattlesnake, and the next time we talk, I'm going to be in a new location. Remember, we've been at Schofield Park on the Rattlesnake Fork, and I'm going to stop this video. Thank you for bearing with me. All right, here we are. I am now at Rocky Nook Park. I'll give you the look around. I'm down here in the creek. There's parking spots up here. Maybe you know Rocky Nook. There's a bridge that way where I can't remember what it's called, crosses over Mission Creek. And this is the main fork of Mission Creek. I'm going to turn around really fast here. Uphill over there, where I just was, is the Rattlesnake Fork, which joined the Tunnel Fork. So now our watershed has grown. We are now in a much larger watershed. This watershed now includes probably triple the land area, so 100, 150 square miles maybe. It's a huge watershed at this point because we took all that Rocky Nook stuff plus more Rattlesnake Fork, and then all the stuff from Tunnel Fork, and we've added all that together. So far, this is still a mostly wild watershed. As a percentage, maybe 1 or 2% is asphalt, which is impermeable, houses, yards, dogs, and trails. But for the most part, that's still a wild watershed up there. So the runoff that we get is still mostly organic material that would have been there without humans, plus maybe a little bit of trash. You know, when I was leaving Rocky Nook Park, I saw a spot where it looked like a human took a leak, and I saw a spot where there was like an aluminum can. I would imagine that between here and the top of East Camino Cielo, there's other accumulated garbage, but in general, I would say this is probably still relatively clean, relatively wild, and it still has relatively high habitat value. Diversity of habitats, it's still shaded, it's still vegetated, it's still mostly native vegetation. Interestingly, along this side of the trail, there's more development. And something interesting happens. When you start to develop a place, you start to clear out niches. So by cutting out all the vegetation and trees that used to be here, that leaves an opening. Now some invasive plant can move in. And remember, invasive plants don't have the same relationships to local wildlife that the native plants did. So we would expect to see in this area more and more invasives, because invasives capitalize on disturbances. That's a good little note to remember throughout the class, that invasives are looking for a way to sneak in. They capitalize on disturbances. Even though it hasn't rained in a long time, there's still some water. Most of this is not surface transport. Most of this is coming out from exposed ground. So most of this is groundwater that came from up canyon. I would assume that when it rains, this is mostly just a little bit of runoff, because up canyon, when it rains, almost everything is absorbed into the ground. I would assume that if you tested this water, you wouldn't really find anything very notable. No particularly high nutrient levels, because there's plenty of nutrient recycling uphill. You might find some inorganic stuff, like plastic might show up in this water, little bits of oil or cigarette butts, but probably not very much. I would imagine that with all of this texture, when water passes, it interacts a lot with the atmosphere. So I would assume that going down canyon, you would still find a pretty decent amount of dissolved oxygen in this water. I want to show you something right before I leave Rocky Nook. But before I go, there's one thing that I need to tell you about. If we were on a field trip, this would be more memorable. If we were on a field trip, I would ask everybody to take 3 breaths without making a sound, and I would ask everybody to listen. So I'm just going to do that right now, okay? It's dorky, but forgive me. I hear some bros talking. I hear a car, right? This is not exactly the wilderness, but it's still more wild than being on campus at the high school. During that quiet time, I heard some wind, I heard some birds, I heard some water moving. And you know, something funny happens. When we talk about aesthetic and recreational values of wilderness, that sounds like some hippie mumbo jumbo, right? I know it when I see it. I've been raised around that. Trust me, I know. It sounds like hippie mumbo jumbo. But you know what's funny? If I had brought an oximeter, you would notice that I have better oxygen saturation in my blood. I have lower blood pressure. I have a slower heart rate. If you tested my digestive system, I would be digesting better here. If you gave me an IQ test, I would score slightly higher than if I took that exact same test back at the high school. You see, it's an intangible value because you can't put a number to it. You can't touch it. You can't show it to someone else. But when you're in nature, you run better. Like, we are evolved to be in small groups in the wild. We are not evolved to be in large groups and squares going to other squares inside of other squares. It is a real value of wilderness that we feel good there. Like, I'm sitting on a rock that is cool. I've got some shade. I see some birds. I don't know. When I was driving over here, I was so angry. This is so awkward. I really don't want to be doing this. But, you know, sitting here in the creek, I kind of started to tune that out a little bit. Hard to ignore these people yelling in the background. Not quite sure what's going on. But yeah, one thing I wanted to do before I forget and before we leave here, I wanted to point out that humans work better in nature, that there is a value to this. The tests are overwhelmingly robust. You're less likely to be violent. You're more likely to forgive an indiscretion. Like, if you find out somebody kicked your dog, you're more forgiving if you're here as opposed to being down in town. So yeah, I feel good here. I feel better here. We started up in a pretty intact wild watershed. We are now in an urban interface watershed. So this is still pretty wild, but I am noticing a little bit more interaction with urbanization. We're closer to the built environment. There's more invasive species. There's probably a little bit more litter in the water. And there's obviously more encroachment by development here. From now on, we're going to get more developed, much more developed, totally developed on the rest of our tour of Mission Creek. I want to stop for a quick second and show you a cool parking spot. And then we're going to go to another place. Okay, turning around the phone now. Okay, well, it gets weirder and weirder. I'm around more people now, so I'm more self-conscious. I'm going to try to be fast, but first I'll show you where we are. This is the bottom of the Rocky Nook Park. So you may know that those are some famous statues made by a local sculptor. This is the creek. It's all dry here. There's the bridge that goes over Mission Creek. This is the parking lot, the bottom parking lot at Rocky Nook. And I'm going to try not to be too loud around somebody's resting spot, but I want to show you this parking area. This happens to be some of the most expensive parking in Santa Barbara. Not that. That's just asphalt. This is plain old asphalt. But that's some really fancy asphalt. Like, really fancy. Like, I can't remember what it was, but like these 5 spots and then those 5 spots over there came out to something like $11 million. I don't remember. It was a lot of money. And the reason this is a big deal is this is a different type of asphalt than that. That's impermeable. When rain hits, all of this area flushes. So all of the oil drops and all the brake dust and all the cigarette butts and all the trash from this would go straight into the creek. But this is a different type of parking. Like, hello, lady, I'm just being weird talking to myself on the phone. Okay. This is a different type of parking. This material lets water pass through. These cost a ton of money because it was young technology when they were made. And these, because they allow the water to absorb, it's called a permeable surface. This is impermeable. This is permeable. Like that dirt back there. When rain hits, it soaks in. So here, oil drops, cigarette butts, plastic trash is less likely to go out to the creek. And here, because there isn't the water vehicle to carry the runoff, we are thus generating less surface water contamination. I don't know, it's not such a big deal, but I just thought it was kind of cool to look at that. We're gonna go someplace else now. All right, so here's the thing. I'm driving. I've got 4 stops left, 3 or 4 stops left. Only done 2 stops so far. And I can't tell you how much I hate myself. I hate seeing myself. I hate hearing myself. I hate imagining that other people have to look at me being me. And like, what the heck's wrong with me? Like, I'm a good dude. Why should I hate myself so much? But this is just so unbelievably awkward. See, when we're on the field trip, I don't even think about it. I'm just focused on my students. I gotta tell you, I love high school kids. I love my job. Obviously, I don't do it for the money. I think that it's neat to talk about this stuff and to have students that want to listen to it. But it's just weird when they're not here. You know, like we can't do that process in the same place at the same time. This has really made me like rethink what it means to teach and why I like to teach. I don't know. If you're still watching this video, I guess you're on my team though, because you're inherently interested in seeing what's going to happen next. So, thanks for sharing that with me. We've got a couple of stops. These will be pretty fast, I think. Hopefully we can finish before the sun goes down. I've already blown a bunch of time on this. Alright, well, anyway, here's my little driving interlude. See, like, what is going on with me? Why do I care so much that you understand me? Why would that matter? I know a bunch of teachers that are like, whatever, they don't know who you are. But I'm like going out of my way to make a video to talk to a phone so that you will better understand my situation. Oh, this is such a trip. I'm about to drive right past my daughter. Okay. We've come down near the intersection of Oak and Alabama. Let's see, I can show you where we are. There's a grocery outlet. This is Alamar. Grocery outlet's back there. That's like the Crocodile Lounge, Lemon Tree Inn, something like that. There's the intersection. Edstrom and Tregonis' office is right there. That was my orthodontist. Maybe you know who they are. That's State Street right there. Okay, so we're like in this little tiny vegetated pocket, but obviously, you know, most of our surroundings here are like pretty urban. My homie Todd used to live in those apartment buildings. That's like a market. Delavina's that way. Like this is the, what do they call that? The community with that one school that everybody likes. I forget. Anyway, so we're like in a pretty urban environment here. But check it out. This creek is kind of natural, right? It's got like little pockets of vegetation, but it's also kind of channelized. I'm gonna stop here and then I'm gonna hop down there. I wanna climb down this stuff and I'm gonna give you a view. So I'll see you again in a minute. So we came down here for a few reasons. Whoa, almost dropped my phone. Okay, we came down here for a few reasons. First, I want to give you a little history lesson of channelization, because right here you can see different types. I always come to the spot. So this is probably the roughest form of channelization. This is Mission Creek, and they just kind of dug it up a little funny. So they probably brought an excavator through here. They might have poured a little bit of concrete. It looks like there might have been some concrete there. They put some, I can't remember what you call those, some posts in the ground to like retain that hillside. That's pretty old school. And then if you look over there, I'll walk over there. If you look over here, there's someone else recording a video apparently. If you look over here, you can see some pretty old school channelization. That's like sandstone brick. And then when the road was expanded, they added those like concrete edges. So as the road gets bigger, they expand the bridge using these supports. Like, look at that, that's fresh. That's just done this year. That was just a stack of bagged concrete that was just left there dry, and as the water soaked in, well, I didn't plan for this, and now it's going to get really complicated. I just ran out of memory on my phone, so I got to really prioritize here. Anyway, those are those bags of concrete that are allowed to wet and dry and become a retaining wall. Back there, it's kind of tough to see. Let me see if I can. Oh, I can. Okay, so that is cages made of wire filled with stone. That's also just formed concrete like we looked at over here. And so here we see the beginnings of urban channelization, but this was done project by project for specific reasons, right? Like to support State Street crossing Mission, or to support Alomar crossing Mission Creek. Something else that you notice down here that I think is kind of interesting is all these drains. See these? All of that is drainage of water. Remember that in a city, we start to think of our creeks, our streams, and our rivers as a way to get rid of stuff. This is now waste disposal. So the reason that you have all of those holes in the wall is because we don't want water all over the surface of our city. And we made the surface of our city impermeable. So to avoid the buildup of water, which is dangerous to drivers and property, now we dump water. What used to be Mission Creek is now a drain. This is like a toilet. We want to flush water. That means our watershed down here is mostly urban runoff. Now we've got a lot of cars, a lot of houses. We've probably got some rose growers and maybe some backyard pot growers and some home gardeners and some fancy lawns. So we're starting to accumulate fertilizers and pesticides. We definitely have a lot of dogs uphill from this spot where I am at the intersection of State and Alomar. There's going to be a lot of dog poop in this run. There's probably a lot of human poop. While my battery died, when my memory stopped, I actually went underneath that bridge and I took a pee. There's all sorts of organic material that are added by humans, and then all sorts of inorganic material too. Like each of those cars, every bump here and there is going to drop a little droplet of oil. Some of those smokers might throw a cigarette butt out the window. Somebody might have to change a kid's diaper in an emergency and leave a diaper over here. I see like maybe a little wrapper, something blue right there. So anyway, we're starting to get dirtier runoff, and we're treating this as a way to dispose of the water. Since it can't soak into the ground, we're just washing the city and then dumping that water. Okay, and now I'm at the end of Oak Park. Here's the bathrooms at Oak Park. Here's that one road that I can never remember the name of. Highway 101's right over there. There's a big parking area. Oh, nice little breeze. The playground is right on the other side of this bathroom. And you'll notice this actually looks pretty legit, right? Because it's a park. And are we or are we not channelized here? We got some stacked rock, kind of permeable, still permeable on the bottom. By the way, I forgot to mention that in the last spot and in this spot, water can still soak into the ground because the canal itself is permeable at the bottom. So we're routing water. In that sense, it's a canal. But you know, this is native, basically all native vegetation here. Yeah, all native vegetation. And so this would feel like maybe an island of riparian habitat. When it rains, I wouldn't be surprised if I saw some ducks. On a couple of field trips, I have seen ducks underneath that bridge over there. Look in that direction. There is some channelization, but this is probably about as far as you could go with some amount of habitat value. You know, I'll bet you that some animals, raccoon, mouse, snake, salamander, probably migratory birds, ducks, even like a mountain lion would be possible here. You know, this still has some habitat value. Keep in mind, we're draining a lot of Santa Barbara. I'm getting pretty close to Mission Street, so we're like pretty dirty, I would say, in terms of runoff. There's a whole city, homeless encampments, bunches of lawns and dogs and cats and parking lots and businesses, Jose peeing underneath the bridge, all sorts of human impacts in this runoff. It's definitely urban runoff at the end of what you might call the last wild section of the Mission Creek watershed. But when I turn around, now this is just pure 100% downtown watershed all the way from here to the ocean. You'll notice that's hard channelization. And it's basically no more riparian habitat and just drainage. This would have essentially zero wildlife habitat value. I'll show you a couple of unique little exceptions on the way out to the ocean. Okay, here we are at our last stop in the creek. The street is called Los Olivos or Olive or something. That's the 101. So you'll hear a lot of freeway noise. That's a little pocket of Mission Creek that still had a little bit of vegetation on the edges. That is the kind of trash you get washing off the freeway. You can see what I mean about how this is now just a method of disposal. And this is, you know, a fairly standard hardened concrete canal. When I was a kid, we used to skate canals like this. Still probably has some potential for fun. But if you ever come down here like at the first rain, you can't imagine how dirty it is. I mean, maybe you can imagine, like, if you look through that little gap, you'll see like cars going by and stuff. Like, that's the freeway. So like every one of those cars, imagine all those oil drips, all that brake dust, all the miscellaneous accidents and bits of glass and people without a place to live who come around here. This is really gross. We're in the middle of an urban watershed now. So, you know, this is not the kind of water quality you would look for. I would imagine that after it rains, if you did do a little water test here, you would probably find really low dissolved oxygen, because you would have very smooth, level water, not a lot of interaction with the atmosphere. And you would also have a whole lot of decomposition here, because basically organic material has not been filtered by the landscape. Organic material has been flushed by the landscape into this one area. So you would expect depressed dissolved oxygen and very little life. This is pretty depressing. It gets much worse, of course. This is Santa Barbara. We've got it about as good as it's going to get for an urban channelized river. By the way, interesting place to show you something cool. They take measurements of water level here, and they use these cables, like clotheslines, to run a water sensor and measure the flow of water, so they can figure out how much water's moving through this river. But aren't you kind of surprised that I have been in a water unit this long? You all know I'm a fisherman, and I still haven't talked about salmon. You're not surprised? I haven't talked about salmon yet because I've been waiting to come here to talk about salmon. Something neat about salmon is they live in the ocean, but they come upriver to go make babies up there. Paul Forrester, the English teacher, he always goes to hike Rattlesnake Trail right above Schofield Park where we started this day. And he always tells me, oh, dude, I saw a couple of steelhead up in those pools, and that's how I know that the salmon are running. They live their whole life out in the ocean. But when there's a lot of muddy, fresh water on the coast, they know that the rivers are running. So in the end of the rainy season, when they find muddy, fresh water at the ocean, they start to aggregate. And when they feel the pressure change of a storm coming, they rush up this river, right? They're cued by the rainfall. They want to come up when the water's going down. Now, historically, we used to have a lot of salmon here. People used to catch a 3-foot steelhead in the Mountain Drive community pretty regularly. It was a common, reliable, good fishery here. But, Civil Corps of Engineers changed all of the rivers. The point being they wanted to dry out so we could build a city. And so in order to dry out for building the city, all of Santa Barbara got channelized. And you can imagine that if this is just a constant slick of rushing water, that's going to be pretty exhausting for those poor salmon. So salmon populations were driven right to the edge of extinction by this channelization. So you remember I showed you that cool parking spot. I want to show you something else. We have here something that you're probably only going to see in Santa Barbara. This is fake river added to a canal. So all of this was built, and then we spent another bazillion dollars to try something interesting. We are adding features that resemble a river in a canal so that the salmon can come up the floodwaters, and then they can pull off and rest in that eddy, catch their breath, rest their muscles, and then get cruising again. All of these bars build a series of pools. You can kind of tell, right, by the leaves that water used to pool here and then water used to pool over there. So they come up plush, 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 like a series of stacked pools. This is called a salmon ladder. And you can tell they've got a place to take a break. That's why that rock is chilling right there, because that's an eddy. So during some flood water, when that thing imagine how heavy the water was moving for that rock to move. That rock came through, and then it kind of tumbled off and settled where the water was more still. So those are little rests, little fake artificial eddies where the salmon could catch its breath and then keep cruising uphill. See, salmon are endangered species. Steelhead salmon in our river are endangered. And so the federal government has a responsibility to protect all endangered species. There's funding for that, set aside in the Endangered Species Act. And a bunch of researchers did a bunch of cool science and figured out that once you've already done all of this channelization and you got a freeway 6 feet away and you got some guy's house 6 feet away, you can't get rid of this channelization. So instead of returning a river, they adapted a concrete canal to allow salmon traffic. Now, when this river is rushing and those salmon down there decide that they're going to try to come up, instead of rushing up a constant gutter they can find a rest, a break in the action. The little eddies for them to rest, and the little bars which ensure that there will be pools of water. Even after the majority of the flood has drained, they got a chance to get up the canyon to go breed up there. I don't know, that's kind of cool. I like talking about salmon, and I thought I would show you, first of all, how channelized things are in the Mission Creek going through downtown. By the way, Mission Boulevard is like Mission Street is just like around that turn. That's Mission right over there. So look at how channelized it is. Also look at how cool Santa Barbara is. Again, more cutting edge environmental stuff because you live in the coolest town for teaching environmental science or for learning environmental science. All right, I'll stop. Well, here I am. I made it. It's not quite dark yet. And I am at the end of Mission Creek. We started at the top of the Rattlesnake Fork, went down to just below the juncture between Rattlesnake and Tunnel Forks. So it's Mission Creek proper at Rocky Nook. We did a couple of stops that had gradual urbanization until we reached fully channelized Mission Creek over by Mission Street. And now I'm next to the pier. There's my truck. There's the old skate park. You know, lighthouse. That's Mission Creek, right there. That's where we were. If you take a pee at Rattlesnake Trail, it's gonna eventually wash through here, I guess. There's the bathroom. There's the pier. God, this is such a nice place to live. Can you believe that you guys are going to pay extra money to go live in Boston or some crap? You could live here. Good God. So, thanks for doing that field trip with me. I just want to review a couple things, and I've got one new bit of information. Still one new thing. Coastal wetland habitat. This is part of an expensive restoration project. Most of these plants were reintroduced by well-meaning environmentalists to try to recreate some coastal wetland habitat. Again, wetlands are nice because they absorb water volume. They turn water nutrients into fixed productivity. And like you see over there in the water, all of those water nutrients support a food chain that in this case is ending in a bunch of American coots and some cool kind of grebes that I can't remember what they're called. You probably see some herons messing around on the edges. Yeah, there's a little, where is it? There you go. Cattle egret, night heron, something else over there. I'm sold. I can't even turn around. Coastal wetland. Yeah, wetlands are nice. There's one thing that I wanted to remind you of. Waterways are a good thing. We want rivers, streams, and canals. You'll notice I don't do that too much in my class. I'm kind of ambivalent about good and bad things. But aesthetically, recreationally, our own well-being, water quality, seafood quality, healthy rivers are in our best interest. Seafood jobs over there in the harbor. All my homies work over there. Seafood tourism, like those guys pay their rent selling seafood that they advertise as coming from that ocean, even though that's probably questionable. Those people come and they make jobs and they pay taxes that support our school and our roads and our cops and our firefighters. We want healthy rivers. It's a nice thing. One thing that I still haven't mentioned anywhere in this class that's kind of important is there's not enough healthy rivers that way. Not enough healthy rivers upstream. There's too much channelization. So we get too much runoff. not enough absorption, not enough nutrient uptake. So when we get eutrophication in this water, this can become anoxic, anaerobic, oxygen sag. No life survives. And whenever you hear aerobic and anaerobic, I want you to think about guts. Remember? Farts, lighting your farts, digestion, anaerobic, methane, all that. If that is anaerobic, well, so is my intestine. So I wonder what might thrive in water when it's anaerobic. Anaerobic bacteria are not good for us. You should not eat poop. I'm videotaping myself saying that in public, the busiest place in all of Santa Barbara. You should not eat poop. Those anaerobic bacteria are bad for you. They will fight the aerobic bacteria in your stomach, make you very, very sick. Food poisoning, poop poisoning. And every now and then, this glorious beach gets shut down because it's so low in oxygen that poopy bacteria think they're in your intestine and they'll thrive. We get elevated bacteria levels, coliform bacteria warnings. And boy, that's a bummer. Because what we do up there can turn this into an intestine. And the bacteria that probably shouldn't have survived all the way down to here will find conditions that let them thrive right where all the junior guards do their junior guard swimming, or right where kids like to play. All right. Thanks for coming on my field trip. I hate COVID for making me do this, but I'm really glad you got to the end of it. Probably going to go chill on the beach for a minute, and then I want to go home. Bye.